It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee. Okay, hi guys. You've asked for this one, so it's just going to be a really quick video, but just talking about relationships in graphs, and in particular how it relates to what we're looking at the moment in using controlling chemistry. So I'm going to talk about firstly what's called a directly proportional graph or directly proportional relationship. So if we've got a graph here, we've got distance over time. So if we're thinking about travelling along a car, we're travelling at 60 k's an hour, so we're travelling at a constant speed, what we're going to find is that our relationship is going to be just, exactly like this. Okay, that as we travel over time, our distance increases, okay, by the same amount we go along here, and so what we have is a relationship. We say that distance is proportional to time. Okay, so we've got a directly proportional relationship. Pretty much normally it goes through the origin over here, because if you haven't started, you haven't travelled any distance, if that makes sense. So it's a linear relationship. We increase by the same amount each time. Distance is proportional to time. It's a constant factor. If we have a look at what we call an inversely proportional relationship, let's say we're still looking again at travelling, but this time we're looking at calculating our speed or graphing our speed versus our time. Okay, so if you increase your speed, so the higher your speed, the less time it's going to take you to travel the distance you need. So you're actually going to get a graph that looks a little bit like this. Okay, so the higher our speed up here, the less time it takes us. All right, the lower our speed over here, the more time it takes us to travel this distance. But it's not a set relationship between the two here. All right. What we talk about here, though, is that we talk about speed, and we use a convention of physics. So speed is proportional to 1 over time. Okay, that's what we call an inversely proportional relationship. Sometimes the best way to see this is to actually plot the graphs. So let me show you here. So what we're looking in chemistry at rate of reaction, temperature versus the rate. So when you do a reaction of temperature, we know that basically a 10-degree rise is approximately equivalent to double the rate. So what we should see is a graph again that looks a little bit like this. Okay, the higher our temperature over here, okay, the faster our rate of reaction, and we get a decreasing temperature, gives us a longer time for our rate. Okay, if we plot over here though, and sorry, it's actually hidden by my video at the moment, so I might just move my video out of the top here. Okay, so if we have a look here at 1 over time, so what that's doing is taking our value. So for example, if we've got a value for 10 seconds, okay, and what we do over here is we do 1 over 10, okay, so we just do 1 over our time. What you find is that you actually get that linear relationship again, or that directly proportional relationship. Okay, you'll see that when you graph it. So that's telling us that there's actually a relationship between the temperature and the inverse of the time. So it's an inversely proportional relationship. So what we say here is that the rate of reaction here is inversely proportional to the time taken, or temperature. Okay, so you can actually talk about an inverse relationship here. So hopefully this explains it a little bit for you. I encourage you to jump online, have a look at some more examples. This is just a really quick video to help you out, okay, particularly with the prac that you'll be doing later this week. So just graph your temperature versus your time. You should see this relationship here, which is inversely proportional. You can show that it's proportional to the inverse by plotting temperature against 1 over time, and you'll get a straight line. Okay, and that's a really good indication that it is actually proportional to the inverse, and you show it's the inverse by having 1 over there. Okay, so hopefully that makes sense. Like I said, if any more questions, come and see me, but just try it out, have a look, do some more research. Hopefully it will help you. Thanks guys, bye.